So today, me and my friends are going to present our physics study case entitled Electromagnets in Manufacturing. But before that, I am going to explain briefly what our agendas are. The first one is theory, the second one is phenomenon, and the third one will be application. But before I proceed to the theory part, I am going to introduce our team members one by one. The first member would be myself. Hello, my name is Aisha Muhammad Ali. The second member would be Nurul Aziza binti Muhammad Tony, and the third member would be Shazwi Shahmi Mahibah Najwa binti Samsudin.
Electricity and magnetism. Electricity can produce magnetism. Meanwhile, magnetism can create electricity. When charges from one piece of matter interact with those from another piece of matter, they produce both electric and magnetic force. So, what is electromagnet? Shortly, electromagnet is a magnetic field produced by an electric current. An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Electromagnets usually consist of wire wound into a coil. A current through the wire creates a magnetic field which is concentrated in the hole in the center of the coil. Electromagnetism. Physicist Hans Christian Ørsted was the first to discover that electric current produces a magnetic field around a wire. To produce a strong magnetic field, wrap coils of wire around an iron rod. Current passing through the coils of wire magnetizes the rod, producing a powerful magnet called an electromagnet. The more loops in the coil, the stronger the magnetic field. Electromagnets are used in electric motors, loudspeakers, televisions, doorbells, trains, and many other devices. Faraday's law of electromagnetic induction states that the process of creating an electric current by moving a conductor through a magnetic field or by varying the magnetic field around it. The majority of the electricity supplied to homes is generated using electromagnetic induction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aziza binti Muhammad Tony, and today in this video we will talk about electromagnetism, a phenomenon where electric currents generate a magnetic field, and we will see how this happens in regular wires, coils, solenoids, and electromagnets. Now, let's imagine having a wire and allowing electric current to flow from the bottom to the top. This current creates a magnetic field around the wire represented by field lines. In this scenario, the field lines form concentric circles around the wire, with the closest circles near the wire indicating the strongest magnetic field. The direction of the magnetic field depends on the current's direction. To remember this, we use the right hand rule. If you curl your right hand into a fist and point your thumb in the current's direction, the direction your fingers curl indicates the magnetic field's direction. For our upward flowing current, the magnetic field would be anti-clockwise, marked by arrows on each concentric circle. However, if another wire has currents in the opposite direction, using the right hand rule with the hand upside down shows that the magnetic field now travels in the opposite direction. To add a bit of complexity, let's consider joining two separate straight wires into single flat circular coil. The current flows in through the bottom left and out through the right. As the magnetic fields of the two sides of our coil interact, the concentric circles of the magnetic fields become stretched out and form ellipses. When these magnetic fields combine, they create a single magnetic field that runs straight through the center of the coil. If viewed from above, it would appear like this. If we increase the number of turns in our coil, arranging them closely in a single long piece of wire, we create something called a solenoid. Importantly, the magnetic field within a solenoid is both strong and uniform. Outside the coil, the magnetic field resembles that of a bar magnet. Similar to a bar magnet, where the field lines emerge is considered the North Pole, and where they converge is the South Pole. Essentially, by using electricity, we have generated a magnet, and for this reason, we refer to it as electromagnet.
Now without further ado, let's dive into the applications. I'm going to talk about 3 applications overall. The first one would be induction cooker, the second one would be MRI, and the last one would be transformers. So now we are going to talk about induction cooker. To make it brief, inside the glass cooktop of the induction cooker, which we called as hob, there is an electronically controlled coil of metal. And the current will then flow through the coil and produces a magnetic field all around it when it is powered on. And a simple direct electric current produces a constant magnetic field, which we know as a law of electromagnetism, and we will then use an alternating current to make a fluctuating magnetic field that indirectly produces heat. And as you can see in the figure I've included in the slide, when a pan is then placed on the cooking zone, the magnetic field will produced by the coil, which is the blue line. And then for the alternating magnetic field, it will induce the whirling electrical currents inside the pan and turning it into a heater, which we can see in the orange lines. Next, we are going to talk about MRI. So MRI is a powerful magnet which produce a strong magnetic field that forces protons in the body to align with the field. So, when the radio frequency field is turned off, MRI sensors are then able to detect energy release as the protons realign with magnetic field. The horizontal tube, known as bore, is an incredibly strong magnet system with a strength of 0.5 Tesla to 2.0 Tesla. Alright, MRI systems use a superconducting magnet which consists of many coils or windings of wires through where the current passes, and there are 2 other magnets are used to a much lesser extent. It is a resistive magnet, structurally like superconducting magnets but like liquid helium. The permanent magnets have constant magnetic fields, but it is too heavy and that would be difficult to construct one that could sustain large magnetic field. Another part of MRI is a coil that transmits radio frequencies waves into a patient's body to confirm to the contour of the body part being imaged, or at least to reside very close to it during exam. And last but not least, we're going to talk about transformers. Transformers is a type of device using electromagnetic inductions to change the voltage of electric current. It contains a pair of windings and functions by applying the Faraday's law of induction. And from the figure I've included in the slide, we can explain that the AC will pass through the primary winding, which creates a varying magnetic flux. So the magnetic field results strike the second winding and generates an AC voltage in winding via electromagnetic inductions. At this point, we will experience some loss of efficiency due to heating in the core, reactive impedance, or other variables. And transformers are capable of drastically changing voltage, and there are 2 types of transformers. The first one is step-up transformers and the second one is the step-down transformers. Step-up transformers will increase the voltage, whereas the step-down transformers will decrease the voltage. And that's basically it from all of us. Thank you for watching. Bye!